Hello, fellow R programmers. Social Informatics 10, in which we are gonna discuss a little bit from R type system and structures, what we have been discussing mostly since the beginning of the semester, and R functions. Last week, this slide was the last slide we were discussing, and next to the technical points that we discussed it together, I told you some psychological point or psychological points about handling new syntaxes you see. For example, last week, I told you when you see such a thing for creating data frame, don't feel intimidated by the appearance complexity in the syntax. Just try to do it as simple as possible. What does it mean as simple as possible? It means that just consider the data. Don't consider row names, don't consider string as factors, and just do that. And if you remember, last week we did exactly these things, and we made our model as simple as possible. After that we didn't do last week, I ask you to start working on the other parts of the syntax, because now you have a base, you know how it works in its simplest shape, so you are more confident and have a higher chance of success regarding doing all the syntax. Now let's go and do the rest in RStudio. Here is what we had last week. And you remember we created data frame and we have put the columns we tag, because we tried them tagged and not tagged. And as you can see, there is nothing about row names and also string as factor. Okay, now just to save time, you see I have them here ready. So everything as for df1, everything is the same as df, just here you see that I put row names. So row names, I put them, and vector, a very basic and helpful data structure in R. So row names, I put this one, keep cut up, this tree, and after that, when I run it, I have this, and after that I get the print, and as you can see, we have the name of the rows. That much simple. So I'm telling you in this way because I want you to get the muscles for R and know that this model repeats itself in the similar situation with other syntaxes, with other commands, in even different libraries, packages. Okay, so now we have the name, and I go and check the structure here. Since I didn't ask for any change in the structure, you see the structure is the same as before. It is data frame, and column 1 is number, column 2 is character, column 3 is number, and column 4 is character. And as you can see, number, and character. Okay, now it's a good time to see what happens if we add string as factors true, because when you keep it empty, it is by default false. Okay, so since you know what is factorizing, since you know what is factor, you can predict the results. See, here we have two columns that present strings, column 2 and column 4, try, hope, victory, and column 4 is patience, passion, and practice. But as you can see, when I take the structure of the F1, they are characters, they are string. But what happens when I click or when I put true in front of strings as factors? It's gonna factorize the string columns. Why we do this? Because mostly we use R for data analytics applications, for data science applications. And in those situations, usually you are working with numbers. And if you have non-numbers, and if you have characters, and if you have strings, usually they are labels. So it's an option that R provides to you to speed up your programming. Because when you are doing a statistical formula, there is no place for um, strings in their original format. There is no place for characters in their original format. We use them because we want to label categories. So it's a very smart uh, option you have when you are doing the code, and it is here, df2 string as factor true. I run this and I get the print. So far everything the same as before, but when I take the structure of this tf2, I get to this print, my friends. So as you can see, call 1 still number, call 3 still number, but call 2 is not character anymore. It is factor. How many levels are there? 3 levels, because they are labels, they are classes, they are categories, and they are hope, try, and victory, the same as you can see here. Please try it yourself and make sure you are completely good with this syntax. And now the new topic today, functions in R. Functions in R are exactly the same as the functions you know through math. The definition is exactly the same. For example, the typical definition of function that we have is this: if x, for example, equals to x plus 1. Okay, it's a typical function that we know from math. In R, you can define functions. For example, you can define exactly these things. What is the syntax? It is the syntax. But remember, we just finished a practice in which we tried to find the simplicity of syntaxes in R behind their appearance, their surface complexity. So here it tells you when you want to define a function, you need to put a name, function name. Because function is an object, like a vector, like a list, like a data frame. So you need to save it somewhere, exactly the same way you did it for the previous examples. For example, what did you call your data frame you just created? df1 and df2. So for your function, you also need to put a name. Very simple. After that, this function is part of your syntax. The same way when you wanted to create a vector, you put C. When you wanted to create a list, you put list. When you wanted to create a data frame, you put data frame. So when you want to create a function, you also put a function. That's a great thing about R, that it is very much close to human language. And after that, when you put this inside the parentheses, you put the arguments. For example, here the arguments is x. Sometimes you have two arguments. For example, we have f, x, y equal xy, for example. So you put all the arguments here. You can handle thousands of arguments here through R easily. And after that, you have the function name. sorry, you have the function object name. You have the name of the command, the type of things you are going to do, and here you are putting the arguments. So what about the expression? For example, here 2x plus 1 is the expression. Here x times y is the expression. Where do you put the expression? Open a curly brackets, you put the expression here, and after that you close the curly brackets. You can listen to this explanation several times, and also here I have put everything written for you. The only point that I didn't cover in my elaboration now is about the return value. When you put, for example, a long function body here, what would be the return value of the function? As you can see, it is the last expression in the function body that you are going to learn it through the examples that we are going to do together. So the first things that we are going to do is going to do an example in R, and I'm going to do it for you, and after that you please follow that. But what type of function we are going to do? We are going to make a function that we are going to name the object roy, R-O-Y, and we want to make a function that do two things. It doesn't have any arguments, and it prints 4 times 2 and 8. Okay, so if you are lost, again listen to this expression, that what type of function I'm gonna make. The name of the function, I'm gonna put y and put this sign. You can use equal function. This is a very great help with R, that as soon as you type something, it brings up the rest. Okay, open parentheses. I can put the arguments here, but I'm not gonna put any argument. So open and close curly brackets. Now I can put anything here. What I'm gonna put here, I'm gonna put this command, print 3 times 4. Sorry if it was something like that. I said in the previous slide, I guess it was 2 by 4, but it's not important. Okay, so I put this, and also I put the answer here, and I make both of them string, and that's it. Now I run this, and I have this run. So what happens when I invoke my function? So I'm invoking it. I have created this function, and now I'm invoking it. And remember, when you want to invoke a function, you should use open and close parentheses. So what we expect when I invoke this function, I expect that R goes and find this function roy somewhere and goes through line by line of the statement. So we expect to see here these two lines, 3 times 4 equals 12. So now I'm here and I run it, and it is the result as I told you. 3 times 4 equals to 12. So you see, when you invoke it, it goes through this name and this function, line by line is run. Now, after doing the things that I just did to have it as a warm-up practice for function that you just started to learn, after that, please do this exercise that I'm telling you. Please do this exercise, that your next function, take one argument, and that argument is the results of 3 times 4. that you put it here and it gets printed.